Hello everybody, it's Mrs. Ortiz and this is section 4.4 for congruent triangles and geometry honors. So today we are going to look at the shortcuts ASA, AAS, and HL and determine what those shortcuts mean in two triangles. So in section 4.3, you learned about two shortcuts, SSS, meaning side, 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 and SAS, meaning side, angle, side, and looked at some examples to determine that those two shortcuts can prove triangles congruent. Okay, now remember that before we had shortcuts, in order to prove two triangles congruent, we had to have all corresponding angles congruent and all corresponding sides congruent. So that's 6 parts. It's 3 pairs of congruent angles and 3 pairs, so 3 pairs of congruent angles and 3 pairs of congruent sides in order to prove that triangles were congruent until we had these shortcuts. Okay, so the 3 shortcuts that I'm going to introduce to you are ASA, AAS, and HL. So based off of yesterday, ASA sounds just like what you probably expect it to be. It stands for angle, side, angle. And so if you have 2 triangles with 2 congruent pairs of angles and a pair of included sides that are congruent, then the triangles are congruent, okay? And so that is the postulate for ASA. So let's come over here and we'll fill that out. Okay, so ASA, probably the hardest part is writing it so that it's actually true. Says if 2 triangles have 2 pairs of congruent angles and the included sides are congruent, then the 2 triangles are congruent. Okay, so you might need to pause and jot that down. And then let's take a look at this picture and the notation. Okay, so there's a reason that it goes in the order ASA. The side has to be between, so the congruent side has to be between the 2 congruent angles. So here are our congruent angles. Angle A is congruent to angle D. Angle C is congruent to angle F. And segment AC is congruent to DF. And that segment is between the 2 congruent angles. So these triangles are congruent by the shortcut ASA. So let's go over here to the notation and say if angle A is congruent to angle D and segment AC is congruent to segment DF and angle C is congruent to angle F, then you can conclude that triangle ABC is congruent to, now be careful, A corresponds to D, B corresponds to E, and C corresponds to F. Okay, so here's your A, S, A. All right, triangle congruence by angle, side, angle. Okay, the next theorem we're going to talk about is angle, angle, side. So this means that your side is the non-included. So let's look at the picture first. So if we go over here and look, so this is angle, angle, side. So now the side is not included in the two congruent angles, okay? So let's go over to the box for the actual theorem and write that. And this time we're going to say if two triangles have two pairs of congruent angles and the let's see here, and the non-included sides, let's see here, it really needs to be and a pair. Okay, so and a pair of non-included sides that are congruent, then the two triangles are congruent. Okay, so again, you might want to pause, jot that down, and I'm going to go back over here to the image and the notation. Okay, so we know this time we're going to say if angle if angle D is congruent to angle A, and angle F is congruent to angle C, and segment EF is congruent to segment BC, then triangle DEF is congruent to triangle ABC. Okay, so like I said, this one is angle, angle, side, because the side is not between the two congruent angles. Okay, so there's two more shortcuts. So our list includes SSS, SAS, ASA, AAS, and then the last shortcut that we have is HL. And so what the heck is HL? All right, so notice here it says if triangle ABC and triangle XYZ are right triangles. Okay, so now we're thinking right triangles. So we've got triangle ABC where C is the right angle. Okay, and then we have triangle and Z is the right angle. So we've got Z here as a right angle, and X and Y. Okay, HL actually stands for hypotenuse leg. Okay, so if you are familiar with the parts of a right triangle, we know that the hypotenuse is the longest side. Okay, so in this case, that would be AB and XY because they are opposite the 90-degree angle, all right? And then a leg is one of the other two sides. So what HL says is if the triangle is right, that's why it's called HL, hypotenuse and leg, the parts of a right triangle. If you have a pair of congruent hypotenuses, okay, so AB is congruent to XY, and a pair of congruent legs, it does not matter which pair either, okay, then the two right triangles are congruent. Okay, so here's the notation. If triangle ABC and XYZ are right triangles where angle C and angle Z are right angles, then segment AB is congruent to segment XY. Then triangle ABC is congruent to triangle XYZ. Okay, sorry, I skipped this was the hypotenuse, and this was the leg and I skipped the leg. All right, so our congruence theorem here is going to say if two right triangles have congruent hypotenuses and a pair of congruent legs, then the triangles are congruent. Okay, so we are going to look at these examples, and it says state whether the triangles are congruent by ASA, AAS, HL, or none. Now what we are not considering right now are SSS and SAS, so we will do all of them together, but right now we just want to focus on the 3 new ones. Okay, so in number 1 we want to determine if the triangles are congruent. So the first thing I notice in number 1 is that it has right angles. Okay, now just because a triangle has right angles does not mean it is automatically HL. All right, you can have right angles and it could still be angle side angle or angle side or even side angle side. All right, but in this case we have a pair of congruent right angles. Okay, so they're right triangles, and then we have these 2 congruent sides, which are legs of a right triangle, and then these 2 triangles share their hypotenuses. Okay, so the hypotenuses is actually one hypotenuse that is shared. That's called the reflexive property. All right, so yes, we have a pair of congruent legs and a pair of congruent hypotenuses. So these triangles are congruent by HL congruence theorem. Okay, HL congruence theorem. All right. Let's take a look at number 2. Okay, so the first thing you want to do is mark the things that are congruent but unmarked. So here we have a pair of congruent angles by vertical angles congruence theorem. And now we're going to look for these triangles to be congruent by either HL, angle side angle, or angle side. So we do have 2 pairs of congruent angles, so it has to be either angle side angle or angle side. And then because our 2 congruent sides are not between our congruent angles, this is angle side congruence. Okay, so these triangles are congruent by angle side congruence theorem. All right, in number 3, and you really don't have to actually worry about if it's a theorem or postulate. This is the one case where we just let you state the reason like that, okay? In number 3, we have 2 pairs of congruent sides. So we have, let's see here, these are congruent and these are congruent, and these triangles appear to be right, all right? So, but you cannot make the conclusion that they are right. We don't know unless they are marked or we're given information otherwise. So all we have here are a side and another side, and side is not a congruent shortcut, so we have no proof that these triangles are congruent. Okay, so that's none. In number 4, we have 2 pairs of congruent angles. Be careful with this one. Just because the lines are staggered does not mean that they're not congruent. It's just so that you can tell where the lines start and stop. So we have a pair of congruent angles here, and we have another pair of congruent angles here. Okay, and then so we've got 2 pairs of congruent angles, so it has to be either angle side angle or angle side, or it can be none. Okay, so we're looking for a congruent side, and we do have it. This shared side right here, remember, called the reflexive side. is congruent to itself. So now we have a side between two congruent angles. So these triangles are congruent by angle, side, angle congruence. Okay, that was number 4. Let's take a look at number 5. In number 5, again, you want to start by marking things that are congruent but are not explicitly given. So now we have those congruent vertical angles, and then we have another pair of congruent angles here. So we've got one pair of congruent angles, the vertical pair of congruent angles, and this third pair of congruent angles as well. So we've got AAA. And AAA is not a way to prove triangles congruent, so we have no proof of these triangles being congruent. Again. Okay, you're going to do 6, 7, 8, 9, 10, and then you can pause now and do those, and then we're going to go down to these two proofs, 11 and 13, and you're going to try number 12 on your own. Okay, so let's take a look at these. So number 11 says, using the law of syllogism, construct an argument using postulates and theorems to justify why JKL is congruent to triangle PML if segment KL is congruent to ML and angle K is congruent to angle M. So the first thing we're going to do is we're going to look at these givens and we're going to mark them on the diagram if they're not already marked. So we've got angle K is congruent to angle M, and then KL was congruent to LM. So we've got that there. The next thing we want to do is make any conclusions from the diagram that were not explicitly given. So we also have from this diagram vertical angles that are congruent at vertex L. So angle JLK is congruent to angle MLP because they're vertical angles. And then we want to decide, are these triangles congruent? And they are by angle, side, angle, and then finish the proof from there. Okay, so we'll just make a note. We've got angle, side angle, and then we also had vertical angles. And let's go in and see if we can fill this out. So from the figure, that means it is coming from the picture, and then we have this angle sign to give us a hint. Angle what is congruent to angle what? So that was angle JLM is congruent to angle MLP. Let's see if I can squeeze this on. So we've got JLM was congruent to angle MLP. And the reason is by the vertical angles congruence theorem. So vertical angles congruence theorem. And then it says also, since KL is congruent to ML and angle K is congruent to angle M by the given statement, then triangle, and then what we're going to do is we're just going to copy this if we're ready to prove the triangle is congruent. JKL is congruent to triangle PML. You should copy the statement exactly as it was given to you. And then we're just going to double check that those correspond. So J corresponds to P, that's good. K corresponds to M, that's good. They both have the one, the congruent angles with the one arc, and then L corresponds to L. All right, so we can conclude this by, what reason could we prove these triangles congruent? ASA congruence. All right, so like I said, I'm going to let you take a try at number 12. Okay, so congruent, proving that those two triangles are congruent. This is a little bit different format where it's just given the information, and then the proof statement is what you're trying to get to. And then I'm going to do number 13 with you. Okay. So again, use the law of syllogism to construct an argument to prove the statement from the given statement. So the given statement is that GK bisects angle FGH. Okay, so remember that a bisector, so FGH, so it's going to cut this angle in half so that these two angles are congruent to one another. And then it says that GK is perpendicular to FH. So we know that perpendicular lines intersect to form right angles. And then the last thing we want to do is look at this picture and see if there's anything else we can conclude. Well, we see that these two triangles share this side GK. So GK is congruent to GK. And because of that, we get that these two triangles are congruent by angle, side, angle, right? And we have angle, side, angle over here as well. Okay, so we're going to formalize that. So our note is that we are proving these triangles congruent by angle, side, angle. So let's see if we can fill in the blanks here. It says the first given statement, so that was GK bisects angle FGH. Okay, tells us what? So what conclusion can you make from that statement? GK bisects angle FGH. The conclusion we made was angle FGK is congruent to angle KGH. Oh, shoot. That goes here. Therefore, here we go. We have the concurrence symbol, so we're going to use context clues. Sorry about that. So angle FGK is congruent to angle KGH by the definition of an angle bisector. All right. So I think what we were looking for here, what makes sense now if I would have read ahead, is that GK bisects angle FGH. All right, context clues are important, sorry, and I even wrote this. Okay, the second given statement says that GK is perpendicular to FH. So GK is perpendicular to FH. So angle blank and angle blank are right angles. So we just need to fill in the two angles that are right. So angle GKF and angle GKH. Since all right angles measure, what do they measure? 90 degrees. Right angles are congruent, and angle GKF is congruent to angle GKH. Okay, so now we have our congruent angles here. Our right angles are congruent, and our congruent angles from the bisector here. Okay, and the last thing that we have to conclude before we can use ASA is that the sides were congruent. Okay, so it says next, GK is congruent to GK because a segment is congruent to itself. Or if you want to go ahead and say the reflexive property, you can absolutely say that. So a segment is congruent to itself, or because of the reflexive property. And if that's the case, then we can conclude that triangle GFK, and notice I'm just going to take it right from the proof statement, it should be exactly the same, is congruent to triangle GHK. Okay, and the reason is by angle, side, angle congruence. Okay, so if we look at this, we have our first given gave us our first pair of angles. So if I put an A here, and then we have another set of angles here, and then we have our congruent sides here. And so we do have angle, side, angle. It's just out of order. Okay, so it's angle, side, angle. And it doesn't matter how you explain it, what order you put it in the proof. It's angle, side, angle because of the triangle where the sides are between the two congruent angles. But we do have all three of those things, and it tells us what the congruent parts are and why they are congruent, what reason we could make that conclusion, okay? All right, so that wraps up section 4.4, ASA, AAS, and HL, and I hope you have a great day. Bye.